Hello everyone. This is Sandeep Kamble from Garage4Hackers. So we are with another Ranchoddas that is with Riyaz Walikar. So today Rahul is going to be give an introduction about Garage4Hackers, how we from the last few years how we performed all these events and all. So Rahul, please can you speak up?
Yeah, I'm not quite sure if it's live, but hey guys, Rahul Shashi here. So we have an awesome talk from Riyaz Walikar about SSRF and XSPA vulnerabilities. So this is going to be a very amazing talk. So before we start the talk, I'll give you a quick introduction about Garage4Hackers, what we do and what we're trying to do and what we will be doing in the future. Our main objective, our main mission is to bring free infosec education to the masses for free. We wanted to connect all the infosec enthusiasts, newbies, infosec researchers, everything under one platform, and that virtual platform is Garage4Hackers. Our community members, we have almost like 4,000 plus registered members, and our combined effort, we have reported almost 40 plus browser security issues to the browser vendors. We often participate in bug bounty programs hosted by Google, Facebook, Yahoo, and multiple other vendors. And the main highlight is whatever bugs we find and we report, we make sure that we make it open for the public on our forums or as blogs on Garage4Hackers. So information sharing is a lot over there. And we conduct regular CTF contests. Could be monthly or could be like quarterly. We even have a chapter meets which happens in Pune, Bangalore. We get associated with null community and OS community to conduct these monthly meetups, which mainly happens in Pune and Bangalore. And we do a lot of research activities over here, which are related to KBKB, biometrics, drone security, lockpicking, fuzzing, or anything which we see which is interesting and fun to hack. We do researches on that. So Riyaz Walikar, he works for Citrix security team, security evangelist. That's what he call himself. One of the OS Bangalore chapter leaders, an active participant of Bangalore Null chapter. He's got the privilege to speak at NullCon, CoCon, Black Hat 2012, OS App and AppSec. You should definitely check out his papers on the internet. And he's an aspiring singer, and having listened to him, I say he's really good. So we thank our sponsors, NetSparker, who've been continuously supporting us for the last many webcasts, and Secure Layer 7, who's also with us, who's also one of our own members startup. If you guys are interested in sponsoring these webcasts, do contact us at info@garage4hackers. And I just wanted to take one more moment to congratulate all the April month CTF winners, Polax, Keyboard Cowboy CTF team, and Adarsh Dinesh from SecFall team. Please join us. We need a lot of fresh blood. We need a lot more contributions to the community. Be a member of the Garage community. You can follow us at Garage4Hackers on Twitter or on the forums, or you can send a mail. I'll hand it over to Riyaz. And if you have any questions or queries during the webcast, please make a hash with the particular hashtag, and we'll be collecting those questions and forwarding it to Riyaz, and he'll be responding back to you. So I'll hand it over to Riyaz. Thanks, Rob.
All right. So the topic of today's webcast is going to be demystifying XSP and SSRF vulnerabilities. I'm calling it demystifying because I've received a lot of questions in the past about how do you identify or what exactly are SSRF and XSPA vulnerabilities, right? So in that context, let's see how I actually began researching these vulnerabilities on the internet. So the entire presentation is going to be in the form of a story, where I'll begin with how I found the first bug. I started researching into bug bounties, and that's where I found the first bug with Facebook. I'll be talking about that, and I'll be also talking about other XSP SSRF bugs I found with other major applications on the internet. Right. Then we'll also see what. Then we'll also see a couple of other things with uh, how do you go about discovering these bugs, and how you would be able to exploit them as well. Uh, uh, Rahul has also done an introduction about me, so I'll just skip this slide. So, where did all of this begin? A long time ago, I was researching vulnerabilities on applications on the internet, and I found a Facebook URL which fetched the title from a URL I could control. Right, so there was a Facebook URL, plugin send button form shell.php, and it had a parameter called node URL. You could provide it another URL on the internet, and it would be able to fetch you the title from that URL. So I tested this for the standard XSS, SQLi, LFIs, and RFIs, right? And I had no luck. So what I did was I set up an HTTP server with port 8080 exposed to the internet, because I wanted to see what was the headers that Facebook was sending. Right? This clearly was a request that Facebook was making to the third-party URL. So I set up a web server, exposed port 8080 onto the internet, and I tried to provide it in the URL. But what happened was I accidentally mistyped 8080 as 808. And I noticed that Facebook displayed an error that hinted on the port being closed. Port 8080 was open, port 808 was not. Right? And I noticed, I tested this with other open and closed ports as well. And I noticed that I could port scan internet facing servers using verbose errors from Facebook. And this meant a lot of things to me. Right? I could use Facebook servers to port scan a different server on the internet. Right? And if you could achieve port scanning to a lot of servers on the internet, Facebook will be held accountable, because you're spoofing the source address. Right? But you can see the results. So what was the basic issue behind this? Facebook was using underlying server-side code to open socket connections to remote servers. Right? It was opening a connection to google.com, downloading the title and displaying it to us. Friendly error messages were being sent to the client for failed socket connections. Right? I'll show you what the error messages were. And based on this, there was no proper data handling for non-HTTP streams. For example, if I would connect to a SSH port, the application behaved differently. When I would connect to an HTTP port, the application would behave differently. Right? And when I reported this, I sent this issue to Facebook, who responded saying that they did not see how this was a problem. I was like, this is clearly a problem. Why don't you understand? Because I can use your servers to port scan servers on the internet. You are going to be held accountable. So based on their response, I created a proof of concept Python port scan. I created a Python script which could be given a URL or an IP address and a list of ports, which would then use Facebook's IP address to scan those machines. I scanned some random servers on the internet using the script. I scanned Microsoft and a couple of other servers on the internet just to see if the POC would work. A couple of days later, Facebook responded and said that this was indeed a problem. I don't know what happened in the backend, but yeah, they acknowledged that this was a problem. Well, then I had stumbled upon a bug, and this was my first bug bounty with Facebook. Going forward, I realized that XSPA, I called the attacks as cross-site port attacks, because I did not find a lot of resources on the internet that spoke about this particular kind of vulnerability, this class of attacks rather, where you would be able to use a server to connect and scan or access other machines on the internet. Right? This was way back in 2011, 2012, when Alexander and the other folks from ERP Scan had not yet made a lot of much of the research public. Right now, when you look at the CWE 918, it's called server-side request forgery, and the cross-site port attacks is one of the alternate terms that is provided for SSRF. So during the entire context of this presentation, I'll be using the terms XSPA and SSRF interchangeably. Right. So what exactly is cross-site port attacks or SSRF? When do you say an application is vulnerable? XSPAs occur when a web application attempts to connect to a user-supplied URL and does not validate the responses that are coming. Right. XSPA would typically allow an attacker to port scan servers, attack services, right, while proxying the attack from another web application. So typically, you would be able to use the server, the web application server, or wherever the connection, the backend socket connection is going to originate from. You could use that server to, do port scan, attack other services, read files on the system, read files on other systems, use other protocols like Gopher and Mail and other things. We'll touch upon a little bit of that later. Right, but the source would always seem to be the web application server or the server from which the socket connection would originate. For example, if you look at the current gravatar.com URL, you have an option of you have a page that says enter the URL of the image on the internet. This is not vulnerable, by the way, but this is an example of a typical page that could be vulnerable. You will have a chance to it says enter the URL of the image on the internet. You provide it a URL and it fetches back the image, right? I have set up an application which I will come to after this slide. We'll take a look at that. So consider an application that allows users to specify an external image URL, which is something like this. The remote server on which the image resides has ports 2280, 3306 open, right? Let's say, for example, if you are going to be you have your gravatar.com URL and you have a completely different server on the internet which has 2280 3306 open, but this is the server from which you're going to be fetching your image, right? In which case, based on the application's behavior, you could specify the file URL plus, right? If you notice, your HTTP remote server image PNG is a standard image 200 OK. The image is actually retrieved. But for your port 22, if you specify a port 22, it says invalid image. If you specify port 3306, it says invalid image. When you say port 8081, it says connection refused. Now, based on these error messages, you can figure out which of the ports are open on that server or not, right? Application displays verbose errors for failed socket connections or receives fixed length responses or delayed responses. And the multiple ways of looking at it. The other thing that applications don't do is applications do not verify received data from the remote server if the connection was successful. Right? If as soon as the port is found open, applications, a lot of applications that I've seen were vulnerable to SSRF XSPA were not able to analyze the response received. They would take the response that is coming in and just generally display it. Which is why I've had a lot of examples where I have been able to do banner grabbing and other things. Right? And also applications that do not blacklist internal IP addresses are also vulnerable. Typical scenario, you have this is the example of how the architecture look on the internet, right? You have a group of determined hackers sitting on, somewhere in a country that we should not name. You have a firewall that is protecting a web server and a couple of other internal servers, right? And you have this is the internet cloud. Okay, now an attacker generates an HTTP request of this form, right? You have your vulnerable server. This is the vulnerable server. It has a PHP script called getimage.php, which takes a get request with the parameter img image, right, which points to the URL of the remote server where you want to download this, right, from. So you have this request. A get request is sent from the attackers through the internet, through the firewall to the vulnerable server. The vulnerable server, based on the URL that was requested, the image that was requested, crafts another request. Okay, the vulnerable server on behalf of the attacker makes a get request to the internet server for the image.png. Right now, this image.png is obtained from the the image is downloaded to the web server, right? The response comes back to the vulnerable server, and a local link is then sent to the attacker. Okay? The page responses, the image response is collected back, and then let this animation get done. So the image response is received, and a page response is created and sent back to the attacker. In the second scenario, consider this: an attacker generates an HTTP request of the form getimage.php image equal to a local IP address on port 22, right? This is definitely on an SSH port and the standard SSH port, but you won't be able to host images there unless you're like running a web server on port 22, which I don't think anybody would do. So what happens in this case? An HTTP GET request is generated, sent to the vulnerable web server. The vulnerable web server, based on the URL that was requested, makes a GET request to the locally accessible server for the image.png. The image response is received. Since the GET is made to a non-HTTP service, the service returns any banners or error messages, ideally the SSH banner, which we'll see in later examples. And this is then sent as page response to the attacker, back to the internet. So based on this, you would be able to port scan internal machines on different kinds of errors that are received. Now, what are the different machines that you can access? Right? What are the different machines you can target? Considering that the attacker is sitting behind the firewall here, right? If this is the attacker, okay, what are the different machines you can access? Through the firewall, because port 80 is open, punching through the firewall using the vulnerable web server, right? The attacker could make an outbound request to a remote server, could make it to an internal testing server, to internal developer machines based on the firewall rules internally, also to itself. Right? Locally, you could use the vulnerability to even port scan the server itself, right? The server that is hosting the web application. So these are a couple of servers I found the vulnerability with. I was able to use the vulnerability in these applications on the internet to port scan, grab banners. In a particular case, I was able to read files on the system and other things. Right? I'll quickly switch to a demo. For example, PHP gives you a functionality to download, or rather to read the contents of a file using the file get contents function. Okay, so if I specify, so what I'm trying to do is I'm trying to get this image. This is the scanme.nmap.org server, which is a server set up by Fidor, creator of Nmap, and you are allowed to port scan this server. Right? So if you want to sharpen your Nmap skills, you can use this server to port scan. So what I'm trying to do is, using the script that I have built, right? Using this script, let us try and fetch this server, fetch the image based on the server. So you have site logo.png, and as soon as I submit, a request from the backend is made using the file get contents. Okay, using file get contents, a request to the backend is made, and you would then be able to. Let me show you the source. Right? If you see, the URL is obtained, file get contents, the post value of the URL is obtained and passed to the file get contents. The data is received and stored inside this images directory. Right? If you see, there's an images directory here which contains the image that was just downloaded. Okay, and then file put contents will simply send the file back to the server using an image SRC object. Right? So in such a case, this is one of the popular examples I've seen on the internet, where you would like a file download feature from a remote server, right? Even RFIs, for example, can be converted into an SSRF XSPA vulnerability. RFIs mostly exist as a subclass. Okay, so what happens if I provide a port number instead of this valid URL? Right? If I have scanme nmap.org, I know port 22 is open. Okay, what happens when I specify port 22? If you notice, it says file get contents fail to open stream, which is typical because it's a non-HTTP request. But what you notice is that the web server, the port number that we tried to connect to sends back the banner because we tried to connect to port 22, right? And here you can not only do port scanning, but you could also fetch the banner from the remote server, right? In other typical cases, you would be, for example, if you would want to fetch a text file, there is another function called the fsock open, which allows you to write to create a socket and write to the socket. I've seen examples of fsock open also being implemented, with this flaw, when you're able to pass a URL or a file server's IP address and port number and a request for a file, and it has typically come back and given this error, right? So let's see if we can fetch. I'm just fetching the robots.txt file, which is public. Yeah, this is. Can I have it downloaded? Just give me a minute. So what I do is I specify the local IP address, the port number, and the file name. Okay. Now earlier today I downloaded the robots file from Microsoft and I saved it in the directory, right? Which you can see this is a perfectly valid functionality. But we will see how we can use, or rather abuse, the fsock open feature to attack other ports. For example, if I put this in a loop and I run it across, I've noticed that there is another service running on the server, on this web server. This port is not accessible via firewall because it's blocked, right? But there is a service running. It says network simple time server, right? So you can actually do banner grabbing, version fingerprinting, and other things as well. All right, coming back to where on the internet does this exist? This has previously been found in a lot of places on the internet, right? And not only limited to port scanning, as I said earlier. Examples of XXE attacks, for example, XML external entity attacks. You can XXE also forms a subclass under XSPA SSRF because XML external entities allow you to connect to a third-party server. Right, the server uses the entity operation to connect to a remote server using either the file or HTTP protocol and fetch data from there. Now you can use an XML external entity attack itself to fetch data from a different port. Right, you could, instead of saying port 80, you could specify other ports and you could use the XXE attack to do a port scan itself. That's another example. So I'll just go through a couple of them. Facebook was pretty easy. The server that I set up was called asgard.publicvm.com. It had port 3389 open, right? Apart from 8080, I had opened a couple of other ports as well. 3389 was open, and depending on the application that is going to be that you're going to be testing, you need to look for typical. They have typically different types of responses that are received. For example, Facebook is a little unique because I found different types of responses for different types of port numbers. So if you notice, data was received, some sort of data was received, but the application generated HTML and displayed this content. The application generated and displayed this content because the port number was above 1024 and it was open. Okay, I had port 22 open as well. Okay, this was port 22. I had port 22 open as well. And if you notice, the HTML is no longer received. It said that could not be reached because the server returned status code 502. The port was open. Okay, so based on these two responses, I have any port open above 1024 was HTML, any port above below 1024 was 502. For a closed port, it was distinctly 503. Okay, so based on three responses that received, I built a port scanner around this, and that's when I scanned a couple of other IP addresses, and I also sent the POC to Facebook. That's when it got accepted as a bug. In the case of Google, the Google Webmasters page, there was this functionality where you could specify a URL, right? And I specified scanme.nmap.org. It said, because this is port 80 and it's open, it said we couldn't find the verification meta tag, right? For a non-HTTP port, non-HTTP open port, it said your server returned an invalid response. For a closed port, it said we were unable to connect to your server, right? So based on these three distinct errors, again, I could script this, I could build a POC and a port scanner, and I can scan machines on the internet. Mozilla was a little interesting because when I reported this to Mozilla, this was the highest bounty that I've made. This awarded me about $3,000, and this was typically interesting because I submitted this as only a port scanning bug, but then the Mozilla team responded back and said that this can actually be used to read files internally. Okay, and which they came back and told me, which I had not expected. You know, the good guys that Mozilla are. Please support Mozilla. So the good guys that they came back and told me that this is actually a bad thing. But the vulnerability typically lied with the way they were parsing the URL. So there was scanme.nmap.org. It said that this is port 80 open. It said that your app failed validation with one error. For a closed port, it said, for an open non-HTTP port, it said content type application X web app manifest JSON blah blah blah. So this was the error that came for a non-HTTP port, which is open. For a closed port, it just said network is unreachable, right? And this is pretty fantastic in retrospect when I see. Yahoo was actually one of Yahoo and Adobe were two bugs that were pretty close to my heart for a lot of things, because I've Garage4Hackers, the team is going to be tweeting the video links for both the Yahoo vulnerability as well as Adobe. They posted on my YouTube channel because the video lag. I'll run the video, but then because of video lag, you guys may not be able to follow this, right? But then let's see what we can do. The Yahoo Developer Network, or the YQL engine that they have, allows you to take a look at HTML content and other things. There are a bunch of other functionality, and mostly people use this to run Flickr queries and other things. But then one of the functionalities that they had was it allowed you to select HTML from a URL you could specify, right? And this was without authentication again. One of the vulnerability was in which again it handled the connection. So if you notice, it says select asterisk from HTML where URL is port 80. If you notice, the HTML here is, if you notice the images site logo PNG, this is the HTML from that port. Okay, but when I say port 22, right, if you notice, if I say select asterisk from HTML where URL is port 22, it gives me the banner, right? It gives me the SSH banner that we just saw earlier, right? And in case of a closed port, it just said Yahoo count 0. It just said Yahoo count 0. Okay, so if you notice, the banner was received, which is again a brilliant thing considering that Yahoo's servers were making these requests in the backend, right? I just play the Adobe video, which again the G4H team is going to be tweeting the link for. And this was one of the best bugs I've found, because this allowed me to do a lot more than port scanning, right? We'll see what it was. Adobe had this feature. This is, all of these bugs are patched, by the way. So they had this API engine, the API Explorer provided by Omnitour, which Adobe had purchased. So you could specify, if you notice, you could specify, this is a simple API functionality that they have. So instead of posting it to the URL that they had, I edited it and posted it to Nmap. and I noticed that it printed back based on the port number the HTML content. Right? I specified port 22, and I noticed that it printed again the banner. Right? So again, I was using Adobe servers to port scan scanme.nmap.org, which is my test server again, that I use for port scanning. So it's able to get the banner from port 22 of scanme.nmap.org. When I specify, so 25 is closed, SMTP port on scanme nmap is closed. So interestingly, I checked for the local server. Now if you notice, when I say 127.0.0.1, which is a loopback address, okay, which is a loopback local host address, I'm connecting to the port 80 of this system itself. Okay, but then I'm not able to right now see any responses. So it just means that the application was running on a different port. So I said 22. It meant that, so when I see this error, access denied for unknown, it means SSH was open, right, on that system. 25 was closed. This was epic because I was able to use the file protocol again to read the etc password file. So I figured out it was a CentOS release. This video is available on YouTube, by the way, on my channel. Because it's a CentOS release, the network configuration information is contained in the sysconfig directory. So I found another IP address on the internal network. Okay. So I then used the bug again, and the SSRF XSPA bug, to point or rather post whatever data to this IP address. There was no web server on it, but I definitely got a response from the SSH server. So what I'm trying to say from this is that you could use SSRF XSPA to get inside the network, right? Considering where your web application is, you can also use it to get inside the network and port scan internal machines, connect to other services and other things. Okay. So what are the other kind of attacks that you can do apart from port scanning, right? The couple of interesting things that have happened, and a lot of research has been done by the ERP scan folks on SSRF. There are several ways by which you can get an application to send data. Right? You have the Gopher protocol, you have the HTTP protocol, the file handlers. Right? As long as an application or a server can be made to open a socket connection, okay, to a different machine, it can be made vulnerable to SSRF XSPA. Okay, attackers can not only access can not only do port scans, but also can access internal applications, perform URL based attacks. You could have an application inside the intranet that is vulnerable to parameter manipulation, because now you are able to send a GET request to that application. Okay, because you are able to now access an application inside the network. You could send your exploit code via the vulnerable application to the internal application. Okay, now even SQL injection, for example, and I've verified this on a couple of demos internally set up. If an application is vulnerable to SQL injection, and based on the database that is running in the backend, right? If you have MS SQL or older forms of MS SQL or Oracle, there are a lot of functionalities that the databases provide for you to open connections to other servers. One of the popular ways in MS SQL, the latest versions, is this feature called the open query. Okay, what you could do is in your SQL injection, for example, I don't have a demo of this setup, but I could show it to you here. So imagine if you have a URL, vulnerable URL, get user.php or KSP, because it was made in SQL. Username, let's say it is Riyaz. Okay, so when I assuming that the user parameter is vulnerable to SQL injection, right, I can, and if it's going to return only one column, I could simply say union select from open tree, and I could specify the host server, host DB, and the query that I would want to run. Select right? But the point being that I can now manipulate the SQL injection to connect to, or rather use the backend database to connect to the host DB. Okay, and the host DB may not necessarily be a database. I could simply use a different server on the local LAN, right? Or connect to a different machine out on the internet. Like I control this, right? Me controlled, and pilferage data directly outside to the internet. Right? So there are several ways in which even SQL injection, for example, clearly can be used to manipulate the application to send data out and perform other attacks. The other thing that you may have noticed is that the get data part is controlled by the attacker. Okay, for example, in our application, our vulnerable application here, I'll just put this and I'll show you. Now, when I say, if you notice, the URL part is 127.0.0.1, okay, :80 / robots.txt. The backend code in this application for the fsoc open file, if you notice, what I'm doing is the get file function here opens a socket connection to the system, which is localhost 127 port 80, right, and sends a get request to the data that we asked. The data in this case is the /robots.txt, right? We can literally control the kind of data we're sending here. We can control the kind of data we're sending here. And in a typical case, right, because if you see, get the /robots.txt, set the host header, and fetch the contents, okay, and read the contents back and display. That's what it does, and that's why you have this, because it sends the get request in the backend, right? But if you noticed, if I send it to a non-HTTP port like 8987, is a simple file, is a simple network time server. I have not blocked it on the firewall, so let's see if we can. Uh, 168.26.101 8987. Okay, it says network simple time server version 101. Please enter your name. The functionality is such that if I provide my name, it says hello, my name. The server time is whatever. Okay, right? So considering that the application, I know it is vulnerable, but then if you notice applications on the internet also, if there are applications that accept data that is coming in and use it in its output, right? You process the data that the user is providing and provide it in the output, it could become vulnerable to a buffer overflow attack, right? And if you have an application, if you have a service running on the inside on your network, right, and if the application is going to be blocked by the firewall and other things, because you control the get data part, right, it would be possible to attack these services and even in certain cases execute code on the internal system, right? And as I said, if you notice, This is a service that's running. I just feed it a chunk of A's. And if you notice, the application is crashed, right? And if you notice, the EIP, I will not go into the details of explaining what a buffer overflow is and other things. It's currently out of syllabus. But then what we can see is 4.1 is the ASCII value for the letter A, and this application is vulnerable because EIP can be controlled. So EIP is the register where the next instruction, what is going to be executed, is going to be stored, and you have area where you can write into. Okay, you can actually paste shellcode. This is an extremely simple vulnerable application. What I'll do is, let us see if we can abuse, or rather, let me just finish this slide. We'll come back to that. The point being that you can, since the get/data part is controlled by the attacker, it will be possible to attack this service, right? I could, in any case, even if I'm not able to exploit this, right, I can simply do a denial of service. We saw the application, we saw the program crash, right? I could simply say 127, 8987/ and a lot of A's or B's or whatever would crash the application. And we'll quickly do that demo. I have the shellcode and other things ready. So I'll just, lots of A's, the jump ESP code and the exploit part. What I'm doing is, because you see, when I say 8987, and when I say 8987, for example, if I just say test, submit, it says hello. If you notice, it says get test, this part. Okay, because what's happening in the backend is the web application creates a request, creates an fsoc open request, sends a get request to 8987. But because 8987 is a non-HTTP service, it's a non-HTTP service, which is why the application accepts the text and says whatever it was received, it sends it back. So it received get test HTTP1. So if you notice, we can control this part, right? We may not be able to control this part, but we can definitely control the test part, right? So in such a case, if the application was available in the internet, I could research and exploit code and other things and provide the exploit code as a get URL, right? I say 8987, lots of A's, and then the exploit code, and say submit. We have code execution on the server, right? We were able to run attacker controlled code on the web server. The application was already crashed, by the way, but then attacker controlled code was executed. This is typically how you can use an SSRF XSPA vulnerability to execute code on the remote server. This is typically an RC using an XSPA SSRF bug, right? With XML external entities and other typical use cases of SSRF, you will be able to read files and other things. Okay, but given that you have the ability to control part of the URL, okay, control part of the URL that is going to be generated, or the data packet that is going to be generated in the backend, you can typically you can do a full attack on the backend machine and compromise the machine, right? From port scanning all the way to complete compromise. Now, in other use cases as well, there are a couple of other use cases that SSRF also supports, SSRF XSPA supports, is that apart from typically when I mentioned that you can attack SQLi and parameter manipulation on the internal networks, and you can control the get data parameter. All of this is mostly via an application that generates a backend HTTP code. It generates an HTTP URL, right? But imagine if there is an application, typically we noticed in SQL injection, where you can use the open query, or in cases of Oracle, you can use the UTL HTTP package, just write that down. In Oracle systems, you can use the UTL_HTTP package. You can do a request. Again, this is based on user equal to Riyaz. You have a SQL injection. You append that and you do a whatever host you want. Host : put whatever 22, depending on how you want, whatever you want to do. And obviously the request you're trying to send is then select, right? You select query or whatever you want, right? The point being that you can send data through even Oracle or MS SQL or other database in the backend, right? So attackers would normally not stop at SQL injection and dumping data. They would want to gain control over the internal systems as well, which is where XSPA can be used, leveraged. XSPA SSRF can be leveraged. But if you notice, the kind of packet that is going to be generated if you're going to use the backend database, in cases of SQL injection, which is a very good example, you will notice that the backend packet that is generated is not HTTP dependent, right? It does not support, there's no GET request that is generated. It's a very service specific, it's a very MS SQL Oracle specific packet that will be generated, right? In which case, if you can control the kind of data, that is being sent, right? The most recent example I can give you, for example, the MS-15034, the popular HTTP sys vulnerability out there right now, which for which there is a current blue screen of death exploit code available, right? The point being that to be able to crash a remote HTTP, an IIS 7.5 above server using this particular vulnerability, you need to be able to control the line 2 of the second data packet, right? If you notice, I can send a GET request, okay, but then the vulnerability does not lie in the GET request, it lies in the range header, right? It lies in the range header minus int of 0xff. I don't remember the number. So the point being that you need to have the ability to add this to the first data packet, so that when the data packet goes through to the backend server, it becomes exploitable. Right now, with all the examples that we've noticed, we can only control this part. Okay, but given that you have the ability, I should have set up a demo for this, but then given that you have the ability to control this part, you could simply specify new line characters, right? You could simply provide your input as, yeah, I should have, and then okay, and HTTP request range header, actually 2 here. I'm skipping the host header part, but then the point being that you can use the typical use cases that we have to control even line 2 and line 3. You can specifically, because you have control on the kind of data that you're passing, you can craft a header that matches the protocol that is expected in the backend, right? For example, for the HTTP sys, you need to be able to control line 2, and because you can specify this is going to be your input in the field, this part is going to be your input, right? And when you provide this part as the input, it automatically in the backend, the packet that will be crafted is going to be, when you send, for example, if you send this, oh, you wouldn't be able to. Why would you do this? An internal machine, for example, an internal web server. If you could do this, the backend GET request that is crafted is simply I'm skipping again the host header, but then range would come up here, right? And you have your whatever. Okay, so what I'm trying to cause here is that you can control the kind of data that is being served right now. Okay, you can typically control the kind of data because you own the packet. You can even set, based on other characters that you use, you can even set the line 2, line 3. In this case, for example, your range header causes the vulnerability, right? Because you can control this header, you can easily set and exploit the service. All right. Oh yeah, typo here, but there's byte here. So yeah, the basic idea is to tell you that multiple lines can be controlled. The entire packet can be crafted based on the attacker's choices, right? Not only the HTTP protocol. For example, SAP has been SAP, the popular finance application that a lot of companies use, has been vulnerable to a lot of XSPA bugs, XSPA SSRF bugs, and not only because SAP offers a web application as well as a thick client on the machine. The kind of packet that is generated can be controlled because you're not dependent on a web application server to be able to do this for you. And you can craft a specific packet based on the needs of packet B that is going to go off to the other server. All right. So how do you fix this? We've almost come to the end of the presentation, but how do you fix this? How do you go about fixing this? Couple of things that are mandatory would be proper response handling, right? You have how do you manage the response that is coming back from a server that may not be an HTTP server, and you properly handle the kind of responses received from remote resources. Like typical functionality would be go fetch an image, but as an attacker I could go fetch anything I want, right? In which case the application should be able to identify the kind of resource that has been received, okay, and then display a proper message to the application. If it's not an image, definitely you could simply say invalid request, right? Error handling and messages. Obviously, you also need to ensure that you don't say port was not found to be open, or port was closed, or this was not a valid image, provide a valid image because this port did not send you a proper image. You need to display generic error messages. And I have given these recommendations to a couple of pen tests that I've done, and where I found this vulnerability, this class of attacks rather. We've been able to get the application to behave certain ways and be protected based on the patches that I'm discussing here. Also, another patch that we could also talk about is you restrict connectivity to HTTP based ports only, right? You restrict connections to HTTP ports. You don't allow your web server to make outbound connections to port 22, for example, or 3389, for example, right? And also you could blacklist internal IP addresses, local host, for example, internal host names, the gateways, all of these can be blacklisted. But this is one of the last things I'm not a big fan of blacklisting or whitelisting, for example. Yeah, so internal IP addresses and other things can be used to create a class of IP addresses you should not be touching. The outbound socket should not be open. The other thing that I kind of skipped is one of the ways by which, even if your application does not, consider the scenario where you have an application which goes and fetches an image from a third-party URL. Okay. Now, based on whether the port is opened or closed, the backend server is going to time out, right? If you have, for example, port 22 open, it connects to port 22. All of this is handled. Response handling is being handled. Error handling is being done. Your rather the third part is not being done properly, but the first two are implemented properly. In which case, the application is going to time out after some time, saying that connectivity to a certain port or connectivity to the URL you provided was not met, or rather a timeout occurred or something like that. Based on the kind of responses, the delay in the responses that are coming in, you'd still be able to script and scan this, use this machine to scan. In which case, what you can do is restrict connectivity to HTTP ports comes in handy, right? And again, blacklisting IP. So there's a catch. You need to be able to test this properly for what works for your system. Like Facebook, for example, the way it is implemented right now, I haven't tested it in recent times, but the way they patched it was that they, for all of for anything that I would provide that was not HTTP, they would simply say invalid request. Right, so that's how they've prevented it. All right, couple of resources that you can use. A couple of resources that I used for my papers as well. The SSRF papers written by Polyakov and the ERP scan, the team there, is fabulous because they talk about different types of SSRFs, trusted as well as remote SSRFs. Port scanning and other things would come under remote SSRFs. And the ability to control data packets. So they have again three more simple partial and full control under remote SSRF. So you can take a look at that as well. All right. Special thanks to a bunch of folks at the Null community for being awesome and everything, and Garage4Hackers again. I'll take questions via email, and this is how you can contact me. I run WinCMD-foo. If you're not following that, please follow. I tweet a lot of Windows one-liner commands and other things. And that's my primary Twitter handle. I'll keep this up. So, Rahul or Sandeep.
Okay, thank you, Riyaz, for giving a great introduction as well as a very depth knowledge about this SSRF and XSPA that is founded by you. And I think there are a lot of interesting vulnerability you just shown us. For example, Facebook, and there is Yahoo. That is really interesting us. And actually, we are finding a lot of bugs regarding this SSRF with the client side or whatever in the projects. So thank you for this great event, and thank you very much for the audience who are listening to us. Please do give us feedback on our Twitter, Facebook, and please join us on Garage4Hackers.com. Signing off, Sandeep Kamble from Garage4Hackers. Thank you very much.